treated with the right medication. While non-alcoholic fatty liver disease may be seen in patients with type 2 diabetes, hepatic glycogenosis is relatively common in type 1 diabetic patients, as shown in figure 15. Although hepatic glycogenosis is often underdiagnosed, a large percentage of diabetic patients will be affected. In our laboratory, we modeled hepatic glycogenosis in rodents, in which diabetes was induced with streptozotocin. Our results suggest that N-indica leaf extract ameliorates this diabetic complication, as reported by Akinola et al. 2010A, and shown in figure 15. These beneficial effects might arise from effective control of blood glucose by the extract, further corroborating related data from our laboratory that the leaf extract of N-indica could be a source of novel chemical entities for treating diabetes. Mr. Vice-Chancellor, does diabetes have any effects on the brain? Of course, it does. The brain is one of the most vital and highly protected organs in the human body. Many attributes that make us human are traceable to this organ. Unfortunately, the high morbidity and mortality associated with poorly controlled diabetes mellitus also involve the brain in a number of ways. Diabetes increases the risk of having stroke at least 4 times. Cardiometabolic risk factors frequently coexist with diabetes and do make diabetic patients more susceptible to developing stroke. Aside from being a risk factor for stroke, much attention has also been drawn to the role of insulin resistance and diabetes in the pathogenesis and progression of neurodegenerative diseases, especially dementia. Diabetes has also been known to have deleterious effects on the cognitive and behavioral function of the brain for more than 100 years. With the growing population of people that live to old age with diabetes-associated cerebral dysfunction will have enormous public health implications. According to Alzheimer's Disease International, an estimated 46.8 million individuals are living with diabetes worldwide. This figure is expected to nearly double every 20 years, rising to almost 74.7 million by 2030 and 131.5 million by 2050. This suggests that new cases of dementia may emerge, or that existing cases may progress rapidly in parallel with increasing incidence of diabetes mellitus. Recent evidence indicates the presence of Alzheimer-like brain pathology in human subjects and laboratory rodents with insulin resistance and high type 2 diabetes. This further suggests a strong association between the duo, as reported by Akinola et al. 2011C, 2012, 2015, 2016, and 2017, and as shown in figure 17. In this regard, while working in the laboratory of Professor Sulyman at the University of Vienna in Austria as a predoctoral research scholar, findings by one of my doctoral students, Michael Gabriel, show that insulin resistance and obesity have adverse effects on memory in mice. This effect was ameliorated by oral treatment with cis sugar from ginger, as published by Gabriel et al. 2020. Thus, our data reports an association between metabolic dysfunction and cognitive impairment, and also provides evidence that ginger contains some chemical substance capable of promoting brain health and cognitive function. In addition, we do have active scientific collaboration with Professor Cardona Gomez and her team at the University of Antigua in Colombia, where my doctoral student, Patience Ojo, worked on the association between metabolic perturbation, stroke, and memory dysfunction in 2019. One of the objectives of our collaborative research was to study how insulin resistance impacted behavior, learning, and memory after global cerebral ischemia. Our data, which was published in Nutritional Neuroscience, showed that pre-existing metabolic dysfunction predisposes to worse prognosis after cerebral ischemia, as reported by Ojo et al. 2020. In other words, obese and all diabetic subjects are likely to have worse neurological and cognitive outcomes following stroke. Furthermore, recent morphological evidence from our laboratory suggests that androgen deprivation and central insulin resistance do combine to facilitate hippocampal cellular, subcellular, and molecular changes that perturb memory and cognitive function, as reported by Yosin and Akinola 2021. However, detailed molecular underpinnings of the above associations between endocrine or metabolic perturbation and cognitive dysfunction are yet to be fully understood and are therefore subject to future research. On my part, my research team at Ilorin will continue to explore the mechanisms by which androgen deprivation, insulin resistance, and all diabetes mellitus induce structural and molecular changes in brain regions that mediate behavioral, cognitive, emotional, and motor functions. We will also continue to take advantage of our international collaborations to achieve this objective. In this regard, one of my doctoral students, Avis Olarewaju, will be visiting the laboratory of Professor Russell of the Department of Genetics, University of Cambridge in the UK, having won the Cambridge Africa Aborada Research Fund to study the modulatory role of curcumin and quercetin on GSK3 activity in the Drosophila model of Parkinson's disease, in a bid to deepen our understanding of the molecular link between diabetes mellitus and neurodegenerative disease. As a matter of fact, Dr. Larewaju has since defended his PhD thesis late last year and is presently in the University of Cambridge pursuing his postdoctoral research. Meanwhile, enlightenment campaigns directed at educating the public on the numerous complications of untreated or poorly treated diabetes mellitus should be intensified. My community service in this regard was the formation of a student-based advocacy group called Diabetes Advocacy Initiative. We have successfully organized visitations to a number of secondary schools within Ilorin metropolis as diabetes advocates. My contributions to developmental neuroscience. Mr. Vice-Chancellor, the field of neuroscience, that is the study of the brain and spinal cord, had aroused my interest since the beginning of my career. Unfortunately, the opportunity to advance anatomy beyond flesh and bones in this field did not come until when I received the prestigious Inaugural Research Fellowship from the International Brain Research Organization in 2012. This fellowship funded my 12-month postdoctoral training in the laboratory of Professor Sharon Giuliano of the Uniform Services University of the Earth Sciences in Bethesda, USA. In Professor Giuliano's lab, I had the opportunity to study the association between gestational exposure to environmental toxin and cerebral cortical dysplasia, environmental toxins and brain developmental defects. Like other congenital anomalies, congenital brain defects may arise as a result of genetic, chromosomal, environmental, multifactorial, or even unknown causes. In some cases, in the absence of obvious gross anatomical malformations, certain individuals may present with such neurological issues as seizure disorders, autism spectrum disorder, mental retardation, and schizophrenia, suggesting underlying cellular or molecular aberrations. Environmental factors that could contribute to neurodevelopmental defects are many and include gestational exposure to organophosphorus, pesticides and herbicides used in farms and homes, heavy metals from mining sites and factories, cigarette smoking, alcoholism, certain drugs, and air pollution, as reported by Omotosho et al. 2014 and 2015, and several others. Also, gestational infection with microorganisms such as the Zika virus, rubella virus, and Toxoplasma gondii, and so on, does have negative implications for brain development and functions. Furthermore, neurodevelopmental anomalies could arise from dietary sources. For example, the seed and fruit of the tropical palm-like plants in the cycad family are known neurotoxins in human and animals. Cycad fruit and seed contain cycacin, which when ingested is hydrolyzed into glucose and methyl ethanol. The latter is responsible for the neurotoxicity of cycacin. Our team has shown that gestational exposure to this toxin in the diencephalic ferrets produces mild mesencephaly in these animals. When compared to the normal ferrets, MAM-exposed ferret pups showed increased and early expression of the neuron-specific potassium chloride cotransporter 2 in inhibitory neurons, as reported by Jampa, Akinola, and Giuliano in 2018. This molecular perturbation manifests as incorrect cortical circuit formation arising from deficient migration of neurons to their definitive cortical lamina. Inhibitory neurons destined for the cerebral cortical layer 4 were lightly affected, resulting in marked reduction in the thickness of this lamina, as reported by Polus, Akinola, and Giuliano 2012, and shown in figures 20 and 21. In some schizophrenic subjects, there is empirical evidence to support significant decreases in the cortical population of the parvabome-positive GABAergic neurons, indicating that gestational factors play an important role in the etiology of some neuropsychiatric disorders. They continue to engage in research that studies the degree to which simultaneous exposure to these factors impact neuronal migration and lamination during corticogenesis. This is one of the future research focuses of my team as a scientist committed to advancing anatomy beyond flesh and bones. My contribution to brain and mental health advocacy. The very fact that maternal ingestion of certain food substances and exposure to environmental toxicants will have profound effects on fetal brain development is a wake-up call to pregnant women to choose their diets with exceptional care. In developing nations where many females are either uneducated or have minimal formal education, there is a need for intensive public enlightenment campaigns to educate our women on the association between gestational exposure to environmental toxins and fetal well-being. Mr. Vice-Chancellor, sir. In a bid to advance neuroscience research and promote mental health in our immediate community, Professor Oluwole and I have championed the establishment of the Ilorin Neuroscience Group, consisting of students and scientists with interest in neuroscience. The group had been periodically organizing radio talks and school visitations within and outside Ilorin. The most recent event was held in April 2021 as a global neuroscience engagement and advocacy program, the goal of which was to motivate our students to pursue a career in neuroscience. Each year, we also join brain advocates all over the world to mark the annual Brain Awareness Week, which holds in the month of March. In this regard, we do have periodic interaction with the public via phone-in radio program that previously aired on Ilorin 89.3 FM, Sobi FM, and Harmony FM. Some of these activities were funded by our personal contributions, with occasional financial support from foreign donors. Distinguished members of the Ilorin neuroscience groups have been instrumental in achieving the objectives of our group. They include Professor Muyo Sari Ajao, Professor Musha Yakubu, Dr. Gabriel Omotoso, and several others. At this point, kindly permit me to thank the Vice-Chancellor of the University of Ilorin, Professor Sulyman Abdulkareem, who approved the hosting of the Hebrew School on Mood Disorders, organized by the Ilorin Neuroscience Group in March 2019, with financial and logistic support from the International Brain Research Organization and the University of Ilorin. This international event, which featured lectures and laboratory workshops on mood disorders, hosted selected postgraduate students and junior faculties from universities in Ghana, Cameroon, and Nigeria. We also had resource persons that included 2 professors from Harvard University in US and 1 from the Uniformed Services University of the Earth Sciences, that is USUS, in US. Our Vice-Chancellor specifically gave approval for the feeding and hotel accommodation of the 3 American resource persons during the week-long program. These events and many more are our own means of checking the rising rate of mood disorders in our immediate society. In conclusion, anatomy continues to take the traditional lead as one of the foundation courses in the undergraduate curricula of medical and allied health professions. Therefore, sufficient provision must be made to ensure adequacy of material and human resources required for teaching and research in anatomical sciences. With continuous training and retraining and the availability of state-of-the-art equipment, anatomists will always be in the frontier of promoting the health of the public through advanced research in virtually all fields of medical science, and also through their involvement in undergraduate and postgraduate medical education. So far, as a woman anatomist, I have dedicated my time, energy, and intellectual prowess to the advancement of medical education and biomedical research, specifically in reproductive endocrinology, diabetes mellitus, and neuroscience. I have also had the privilege of providing administrative and academic leadership, previously as level advisor, postgraduate programs coordinator, acting head of the Department of Anatomy, and presently as Dean of the Faculty of Basic Medical Sciences. As a mentor, I have as well provided academic and research leadership to the next generation of anatomists, having successfully supervised 20 masters and 9 PhD students in anatomy. In the years ahead, I intend to continue to devote my energy to the noble cause of advancing human anatomy beyond flesh and bones through active teaching, advanced research, and impactful community service. Recommendations to the government. The illegal mining activity in some parts of the country is not only fueling insecurity, but is also a public health concern. High mobility and mortality have been reported in the affected communities, including brain damage and rates of fertility, arising from leg toxicity, for example. The government should therefore ensure that mining activity is strictly regulated in the interest of mental and reproductive health of the people. Given the relatively high incidence of underweight male pupils in Nigerian public schools, the National Homegrown School Feeding Program of the federal government and a similar program recently announced by the Kwara State government should be continued and improved upon in the best interest of the pupils in our public schools. 3. It is high time that government at the federal, state and local levels consider the establishment of forensic DNA databases and forensic laboratories, that is crime laboratories, across the country to check the high rate of crimes in our nation. With the aid of forensic DNA profiling, that is DNA fingerprinting, it is easier to track and prosecute offenders, and by so doing enhance national security. Graduates of our BSc Anatomy degree program are a source of skilled human resource that can be given short training to operate such crime laboratories. To the university, the approval to run the BSc degree program in anatomy in Nigerian universities is a commendable step taken several years ago by the National University Commission. It is heartwarming that a number of public and private universities are currently running this degree program with the objective of producing competent anatomical sciences personnel to serve as lecturers and scientists in our medical schools. This legacy should be sustained with the proviso that undergraduate admission into the program is not bloated for proper training. 2. Renewed research efforts are recommended to check the high mortality and morbidity associated with diabetes mellitus. In this regard, robust intramural national research grants should be made available to medical scientists to facilitate the discovery of new and highly effective and cost-effective diabetes therapies. Specifically, TED funds through the National Research Fund should do more to support numerous excellent proposals submitted by medical researchers each year. 3. Being a structural science, modern research equipment and facilities that promote high-resolution visualization of tissues, cells, and subcellular structures are required in the anatomy research laboratories. A situation where non-Nigerian universities can boast of functional transmission electron and confocal microscopes is worrisome. Universities should therefore pursue the establishment of electron and confocal microscopy suites for teaching and research purposes to reposition morphologies to deliver beyond flesh and bones. The age-long belief that blames infertility solely on females is not only incorrect, but is also unfair. Male factor infertility is real. Males should therefore not hesitate to promptly present themselves for medical attention in the event of infertility in the family. The problem could be traceable to them in nearly half of the cases. 2. Diabetic patients should desist from self-medication. Rather, they should seek prompt medical attention. When untreated, diabetes mellitus will result in several complications that, amongst others, include psychiatric and cognitive problems. 3. Congenital anatomical or functional defects of the brain will arise from exposure to environmental toxins and ingestion of certain food substances during pregnancy. Pregnant women should therefore avoid exposure to such substances in the best interest of fetal brain and well-being. Acknowledgements. It is nearly 5 decades since my birth into the Akinola family. I am therefore indebted to the Lord for sparing my life to date and for helping me to attain the peak of my academic and research career. I would like to appreciate everyone in this auditorium for honoring my invitation. Several individuals who are too numerous to mention have been part of my journey so far and have contributed in different ways to making me who I am today. Mr. Vice-Chancellor, sir, may I seek your kind indulgence to publicly acknowledge and appreciate a few of them, starting with this song. Ẹ ṣé olóore, ẹ ṣé olóore, ẹ ṣé olóore, olóore. Firstly and most importantly, I give all glory, honor, and adoration to the Almighty God and the Father of my Lord and Savior Jesus Christ for making this day a reality. The story of my academic journey testifies to the benevolence and goodness of the Lord, as written in James chapter 1, verse 17, and underscores the biblical saying that by strength shall no man prevail. 1 Samuel chapter 2, verse 9. I am grateful to my academic fathers in anatomy at Ilorin, Professor Castin Martins of blessed memory, and Professor B.U. Enaibe. Under his supervision, Professor Castin Martins gave me the privilege of becoming the first graduate of the PhD degree program in anatomy at the University of Ilorin in 2011. Unfortunately, he passed on in December 2012. May his soul rest in perfect peace. I am also grateful to other academic mentors who have been part of my story at undergraduate and postgraduate levels, including Professor Soladoye, Professor Odekunle, Professor Balogun, Professor Bewaji, and several others. I learned a lot. I profoundly thank Professor Agaja, a former HOD of anatomy, who was more of a father to me. I appreciate my HOD and academic colleagues in the Department of Anatomy, University of Ilorin, including Professor Enaibe, Professor Ajao, Professor Lawepo, Dr. Amatosho, Dr. Yewobo, and several others that I will not be able to mention here. I also appreciate all the technical and administrative staff of anatomy, including Mr. Biola, retired, Mr. Ulola, Mrs. Abaje, and many others that I will not be able to mention. I am thankful to the staff of the Faculty of Basic Medical Sciences, including Mrs. Shadi Aduloju, who is the faculty officer, and her team. I also appreciate all professors in the College of Health Sciences, specifically those of the Faculty of Basic Medical Sciences, including the late Professor A.A. Adeshokan, who was a member of my PhD panel of examiners at Ilorin. I am deeply indebted to my former dean, Professor Afolayan. I appreciate you, sir. I must thank the Provost of the College of Health Sciences, University of Ilorin, Professor Timothy Olariwaju Adedoyin, for his usual support. I also appreciate past deans and provosts, including Professor Motosho, Professor Soladoye, Professor Johnson, Professor Okeshina, and Professor Akande. I sincerely and deeply appreciate the Senate and authorities of the University of Ilorin, led by our amiable Vice-Chancellor, Professor Sulyman Abdulkareem, during whose tenure I got promoted to the rank of full Professor of Anatomy. I also thank the DVCs and the University Registrar, Dr. Oluwole. My appreciation goes to all my academic colleagues and friends, including Professor Lawrence Olatundi and Professor Victor Oyele of the Department of Physiology, Dr. Rotimi Iron of OAU, Dr. Olufunke Dosumo of Unilag,